In this video, we're going to find more values of theta in standard position. So we're going to find, in these examples, 2 values of theta for every ratio given. And the only thing that's different in this example than the previous is you should note here that we're looking for theta between 0 and 2 pi. As soon as we see that, we know we're looking for radians. So the first thing we're going to do is go to our calculator and change it to radian mode. So now that we're in radian mode, we can use our calculator. And on the side here, we're going to draw our axis, and we're going to put two things. First, we're going to write all things positive, sines positive, tans positive, and cosines positive, just so we remember which quadrants we're looking in. And then we're going to write, this is 0, this is 90, but we're in radians. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. And hopefully that'll help us remember how to subtract or add depending on which quadrant we're in. So for example A, we have sine theta equal to 0.3090. So we're going to start using the same procedure we've used in the other questions. Find the reference angle. So this time, sine inverse of 0.3090, which gives us a reference angle of sine inverse of 0.309, 0.314, 1 to 4 decimal places, or 4 significant digits. Now, that's radians, because we're working in radians. So now we're going to just figure out the quadrants first. So sine is positive in quadrant 1 and quadrant 2. So our angles then, in quadrant 1, the reference angle and theta are the same. So there's our quadrant 1 angle. In quadrant 2, in degrees, we've done 180 minus the reference angle, but we're not in degrees, we're in radians, so this time it's going to be pi minus the reference angle. And that's going to tell us then that we have pi, so pi is over the exponent button here, or we can just use 3.14, minus 0.3141, and that tells us that we have 2.827 radians. And so there's our two answers. Same procedure, only now instead of 180, we've used pi. And then really there's nothing else different. So the following examples then, B, we have reference angle is inverse cosine. We ignore the negative, same as before, to force the calculator to tell us the reference angle in quadrant 1. So cosine inverse of 0.9135 tells us we have 0.4190 rounded to 4 significant digits. Cosine is negative, so that tells us we're in quadrant 2 and quadrant 3. So we have theta in quadrant 2 is pi minus the reference angle, so 4190. In quadrant 3, theta is equal to pi plus the reference angle. And if you're struggling figuring these out in radians, think of it in degrees. It would be 180 plus the reference, so while we don't have 180, we have pi. And if we do this on the calculator, we get our two answers. So first we have 2.723, and second we have 3.561, rounded to 4 significant digits. So there's our two angles. We'll continue with the rest then. Here, the reference angle is tan inverse. Ignore the negative. So we go ahead on our calculator, tan inverse 0.2126. We get the quadrant 1 reference angle of 2095. Tan is negative. Tan is negative in quadrant 2 and quadrant 4. So we're looking at quadrant 2 is pi minus the reference angle, and quadrant 4 is going to be 2 pi, because normally it's 360, so 2 pi minus the reference angle. And if we get those, we get pi minus 0.2095 and 2 pi minus 0.2095. And those are our two answers. So 2.932 to 4 significant digits and 6.074 to 4 significant digits. Next example, we have cotan, but we don't want cotan. We want tan, so we're going to do this in one step here. We want tan inverse, but we can't take tan inverse of this. It's the reciprocal, so it's 1 over 1.860. If that was too quick, write the first two steps on your own and make sure you see where that came from. So tan inverse of that is 0.4933 rounded to 4 significant digits. Cotan positive means tan is positive, so we're looking in quadrant 1 and quadrant 3 here. So in quadrant 1, the angle is equal to the reference angle, so we don't have to do anything with that one. In quadrant 3, we get pi plus the reference angle, which gives us 3.635 radians. So there's those two angles. So in E we have secant, but we don't want secant, we want cosine. So we take the reciprocal, put the negative on top. But when we find the reference angle, we ignore the negative, so it's just with the positive. So the reference angle then is going to be cosine inverse 1 over 1.307. And that's going to give us 0.6996 rounded to 4 significant digits. Secant negative means cosine negative, and cosine is negative in quadrant 2 and quadrant 3. So again, we're just following the same procedure. Reference angle, quadrants, and then find theta. So in quadrant 2, it's pi minus the reference angle. And in quadrant 3, it's pi plus the reference angle. So in this case, our two answers are 2.443 and 3.841. So those are our two angles there. Final example like this, well, we have the reference angle is going to be the sine inverse. Why the sine? Because cosecant is reciprocal for sine, and we don't have a cosine or cosecant inverse. We need to take the reciprocal of that. Again, if that's too fast, try writing it on your own and see how we get to that. Sine inverse then of 1 over 394 gives us 0.2566 to 4 significant digits. Cosecant is positive, which means sine is positive, and that's quadrants 1 and quadrants 2. Quadrant 1, the reference angle and theta are equal. Quadrant 2, theta is pi minus the reference angle. Gives us an angle of 2885. And so there's that final answer. We're going to go ahead now, even though this video has gone a little longer than I wanted, to find example 9. That'll finish this section for us. So we're looking for sine, cosine, and tan in exact values here for a terminal side that goes through this point, and we've done these kind of questions already in quadrant 1, but you'll notice this is -6 and 8, so -6 and 8 is over here in quadrant 2. And what that means is we're looking for this angle, but we use this reference angle. We drop this perpendicular here. The x value, because this point is -6, 8, the x value here is -6. The y value is 8. And if we use Pythagorean theorem to find r, we end up with r is the square root of 8 squared plus -6 squared. And that's going to tell us r is 10. So now we just need to write the sine of theta, cosine of theta, and tan of theta. And sine is opposite over hypotenuse, or y over r. Cosine is adjacent over hypotenuse, or x over r. And tan is opposite over adjacent, or y over x. And if we fill in those values from our diagram here, y is 8 over the radius of 10, or 4 over 5. X is -6 over 10, or -3 over 5. tan is y is 8 over negative 6 for x, which is negative 4 over 3. Just as a quick thing to check, sine is positive in quadrant 2, so that makes sense. Cosine is negative in quadrant 2, so that makes sense. And tan is also negative in quadrant 2. So our answers make sense that way. Our diagram looks good, so that's that answer. Now that's a lot in that video. I hope you tried these on your own and you got the right answers. If not, you should get some help, so come see me, email me, ask in class, go to the Math Help Center. There's lots of options available, but make sure you're understanding these. And we'll see you in the next lesson.